A famous example, Schrödinger's cat, 1935, presents a cat that might be alive or dead, depending on an earlier random event. It illustrates the problem of the Copenhagen interpretation applied to everyday objects. A thought experiment or Gedanken experiment, from German, considers some hypothesis, theory, one or principle for the purpose of thinking through its consequences. Given the structure of the experiment, it may or may not be possible to actually perform it, and if it can be performed, there need be no intention of any kind to actually perform the experiment in question. The common goal of a thought experiment is to explore the potential consequences of the principle in question. Famous examples of thought experiments include Schrödinger's cat, illustrating quantum indeterminacy through the manipulation of a perfectly sealed environment and a tiny bit of radioactive substance, and Maxwell's demon, which attempts to demonstrate the ability of a hypothetical finite being to violate the second law of thermodynamics. Overview. The ancient Greek deiknymi, or thought experiment, was the most ancient pattern of mathematical proof, and existed before Euclidean mathematics, where the emphasis was on the conceptual rather than on the experimental part of a thought experiment. Perhaps the key experiment in the history of modern science is Galileo's demonstration that falling objects must fall at the same rate regardless of their masses. This is widely thought to have been a straightforward physical demonstration involving climbing up the Leaning Tower of Pisa and dropping 2 heavy weights off it, whereas in fact, it was a logical demonstration using the thought experiment technique. The experiment is described by Galileo in Discorsi e dimostrazioni matematiche, 1638, literally, mathematical discourses and demonstrations, thus, Salviati. If then we take 2 bodies whose natural speeds are different, it is clear that on uniting the 2, the more rapid one will be partly retarded by the slower, and the slower will be somewhat hastened by the swifter. Do you not agree with me in this opinion? Semplicio. You are unquestionably right. Salviati. But if this is true, and if a large stone moves with a speed of, say, 8, while a smaller moves with a speed of 4, then when they are united, the system will move with a speed less than 8, but the 2 stones, when tied together, make a stone larger than that which before moved with a speed of 8. Hence the heavier body moves with less speed than the lighter, an effect which is contrary to your supposition. Thus you see how, from your assumption that the heavier body moves more rapidly than the lighter one, I infer that the heavier body moves more slowly for. Although the extract does not convey the elegance and power of the demonstration terribly well, it is clear that it is a thought experiment rather than a practical one. Strange then, as Cohen says, that philosophers and scientists alike refuse to acknowledge either Galileo, in particular, or the thought experiment technique in general for its pivotal role in both science and philosophy. The exception proves the rule. The iconoclastic philosopher of science, Paul Feyerabend, has also observed this methodological prejudice. 5. Instead, many philosophers prefer to consider thought experiments to be merely the use of a hypothetical scenario to help understand the way things actually are. Variety. There are many different kinds of thought experiments. All thought experiments, however, employ a methodology that is a priori, rather than a posteriori, in that they do not proceed by observation or physical experiment. Thought experiments have been used in a variety of fields, including philosophy, law, physics, and mathematics. In philosophy, they have been used at least since classical antiquity, some predating Socrates. In law, they were well known to Roman lawyers quoted in the Digest 6 and physics, and other sciences. Notable thought experiments date from the 19th and especially the 20th century, but examples can be found at least as early as Galileo. Origins and use of the literal term. Johann Witt Hansen established that Hans Christian Ørsted was the first to use the Latin-German mixed term Gedanken experiment, lit. Thought experiment, circa 1812 period 70. Ørsted was also the first to use its entirely German equivalent, Gedankenversuch, in 1820. Much later, Ernst Mach used the term Gedankenexperiment, in a different way, to denote exclusively the imaginary conduct of a real experiment that would be subsequently performed as a real physical experiment by his students. 8 Physical and mental experimentation could then be contrasted. Mach asked his students to provide him with explanations whenever the results from their subsequent, real, physical experiment differed from those of their prior, imaginary experiment. The English term thought experiment was coined as a calque from Mach's Gedankenexperiment, and it first appeared in the 1897 English translation of one of Mach's papers. 9 Prior to its emergence, the activity of posing hypothetical questions that employed subjunctive reasoning had existed for a very long time, for both scientists and philosophers. However, people had no way of categorizing it, or speaking about it. This helps to explain the extremely wide and diverse range of the application of the term thought experiment once it had been introduced into English. Uses. In its broadest usage, thought experimentation is the process of employing imaginary situations to help us understand the way things really are, or, in the case of Hermann Kant's scenarios, understand something about something in the future. The understanding comes through reflection upon this imaginary situation. Thought experimentation is a priori, rather than an empirical process, in that the experiments are conducted within the imagination, i.e., Brown's, 1993, laboratory of the mind, and never in fact. Thought experiments, which are well-structured, well-defined hypothetical questions that employ subjunctive reasoning. Aerialist moods, what might happen, or what might have happened if, have been used to pose questions in philosophy at least since Greek antiquity, some predating Socrates, see Usher 1991. In physics and other sciences, many famous thought experiments date from the 19th and especially the 20th century, but examples can be found at least as early as Galileo. Thought experiments have been used in philosophy, physics, and other fields such as cognitive psychology, history, political science, economics, social psychology, law, organizational studies, marketing, and epidemiology. In law, the synonym hypothetical is frequently used for such experiments. Regardless of their intended goal, all thought experiments display a patterned way of thinking that is designed to allow us to explain, predict, and control events in a better and more productive way. Theoretical consequences. In terms of their theoretical consequences, thought experiments generally challenge or even refute a prevailing theory, often involving the device known as reductio ad absurdum, as in Galileo's original argument, a proof by contradiction. Confirm a prevailing theory. Establish a new theory, or simultaneously refute a prevailing theory and establish a new theory through a process of mutual exclusion. Practical applications. Thought experiments can produce some very important and different outlooks on previously unknown or unaccepted theories. However, they may make those theories themselves irrelevant and could possibly create new problems that are just as difficult, or possibly more difficult to resolve. In terms of their practical application, thought experiments are generally created in order to challenge the prevailing status quo, which includes activities such as correcting misinformation or misapprehension, identify flaws in the argument presented, to preserve, for the long term, objectively established fact, and to refute specific assertions that some particular thing is permissible, forbidden, known, believed, possible, or necessary. Extrapolate beyond, or interpolate within, the boundaries of already established fact. Predict and forecast the, otherwise, indefinite and unknowable future. Explain the past. The retrodiction, postdiction, and hindcasting of the, otherwise, indefinite and unknowable past. Facilitate decision-making, choice and strategy selection. Solve problems and generate ideas. Move current, often insoluble, problems into another, more helpful and more productive problem space, e.g., see functional fixedness. Attribute causation, preventability, blame, and responsibility for specific outcomes. Assess culpability and compensatory damages in social and legal contexts. Ensure the repeat of past success, or examine the extent to which past events might have occurred differently. Ensure the future avoidance of past failures. In science, scientists tend to use thought experiments in the form of imaginary, proxy experiments which they conduct prior to a real, physical experiment. Ernst Mach always argued that these Gedanken experiments were a necessary precondition for a physical experiment. In these cases, the result of the proxy experiment will often be so clear that there will be no need to conduct a physical experiment at all. Scientists also use thought experiments when particular physical experiments are impossible to conduct. Carl Gustav Hempel labeled these sorts of experiment theoretical experiments in imagination, such as Einstein's thought experiment of chasing a light beam, leading to special relativity. This is a unique use of a scientific thought experiment, in that it was never carried out, but led to a successful theory, proven by other empirical means. Relation to real experiments. The relation to real experiments can be quite complex, as can be seen again from an example going back to Albert Einstein. In 1935, with two co-workers, he published a famous paper on a newly created subject called later the EPR effect, EPR paradox. In this paper, starting from certain philosophical assumptions, 10 on the basis of rigorous analysis of a certain, complicated, but in the meantime assertedly realizable model, he came to the conclusion that quantum mechanics should be described as incomplete. Niels Bohr asserted a refutation of Einstein's analysis immediately, and his view prevailed 11, 12, 13. After some decades, it was asserted that feasible experiments could prove the error of the EPR paper. These experiments tested the Bell inequalities published in 1964, in a purely theoretical paper. The above-mentioned EPR philosophical starting assumptions were considered to be falsified by empirical fact, e.g., by the optical real experiments of a Lane aspect. Thus thought experiments belong to a theoretical discipline, usually to theoretical physics, but often to theoretical philosophy. In any case, it must be distinguished from a real experiment, which belongs naturally to the experimental discipline, and has the final decision on true, or not true, at least in physics. Causal reasoning. Generally speaking, there are 7 types of thought experiments in which one reasons from causes to effects, or effects to causes. Prefactual. Prefactual, before the fact, thought experiments speculate on possible future outcomes given the present, and ask what will be the outcome if event E occurs. Counterfactual. Counterfactual, contrary to established fact, thought experiments speculate on the possible outcomes of a different past, and ask what might have happened if A had happened instead of B. E.g., if Isaac Newton and Gottfried Leibniz had cooperated with each other, what would mathematics look like today? Semifactual. Semifactual thought experiments speculate on the extent to which things might have remained the same, despite there being a different past, and asks the question even though X happened instead of E, would Y have still occurred? E.g., even if the goalie had moved left rather than right, could he have intercepted a ball that was traveling at such a speed? Semifactual speculations are an important part of clinical medicine. Prediction. The activity of prediction attempts to project the circumstances of the present into the future. Hindcasting. The activity of hindcasting involves running a forecast model after an event has happened in order to test whether the model's simulation is valid. Retrodiction, or postdiction. The activity of retrodiction, or postdiction, involves moving backwards in time, step by step, in as many stages as are considered necessary, from the present into the speculated past, in order to establish the ultimate cause of a specific event, e.g., reverse engineering. And forensics. Backcasting. The activity of backcasting involves establishing the description of a very definite and very specific future situation. It then involves an imaginary moving backwards in time, step by step, in as many stages as are considered necessary, from the future to the present, in order to reveal the mechanism through which that particular specified future could be attained from the present. In philosophy, a thought experiment typically presents an imagined scenario with the intention of eliciting an intuitive or reasoned response about the way things are in the thought experiment. Philosophers might also supplement their thought experiments with theoretical reasoning designed to support the desired intuitive response. The scenario will typically be designed to target a particular philosophical notion, such as morality, or the nature of the mind, or linguistic reference. The response to the imagined scenario is supposed to tell us about the nature of that notion, in any scenario, real or imagined. For example, a thought experiment might present a situation in which an agent intentionally kills an innocent for the benefit of others. Here, the relevant question is not whether the action is moral or not, but more broadly whether a moral theory is correct that says morality is determined solely by an action's consequences. See consequentialism. John Early imagines a man in a locked room who receives written sentences in Chinese and returns written sentences in Chinese according to a sophisticated instruction manual. Here, the relevant question is not whether or not the man understands Chinese, but more broadly, whether a functionalist theory of mind is correct. It is generally hoped that there is universal agreement about the intuitions that a thought experiment elicits. Hence, in assessing their own thought experiments, philosophers may appeal to what we should say, or some such locution. A successful thought experiment will be one in which intuitions about it are widely shared. But often, philosophers differ in their intuitions about the scenario. Other philosophical uses of imagined scenarios arguably are thought experiments also. In one use of scenarios, philosophers might imagine persons in a particular situation, maybe ourselves, and ask what they would do. For example, John Rawls asks us to imagine a group of persons in a situation where they know nothing about themselves and are charged with devising a social or political organization. See the veil of ignorance. The use of the state of nature to imagine the origins of government, as by Thomas Hobbes and John Locke, may also be considered a thought experiment. Søren Kierkegaard explored the possible ethical and religious implications of Abraham's binding of Isaac in fear and trembling. Similarly, Friedrich Nietzsche, in On the Genealogy of Morals, speculated about the historical development of Judeo-Christian morality, with the intent of questioning its legitimacy. An early written thought experiment was Plato's allegory of the cave. 14. Another historic thought experiment was Avicenna's floating man thought experiment, in the 11th century. He asked his readers to imagine themselves suspended in the air, isolated from all sensations, in order to demonstrate human self-awareness and self-consciousness, and the substantiality of the soul. 15. Possibility. The scenario presented in a thought experiment must be possible in some sense. In many thought experiments, the scenario would be nomologically possible, or possible according to the laws of nature. John Early's Chinese room is nomologically possible. Some thought experiments present scenarios that are not nomologically possible. In his Twin Earth thought experiment, Hilary Putnam asks us to imagine a scenario in which there is a substance with all of the observable properties of water, e.g., taste, color, boiling point, but which is chemically different from water. It has been argued that this thought experiment is not nomologically possible, although it may be possible in some other sense, such as metaphysical possibility. It is debatable whether the nomological impossibility of a thought experiment renders intuitions about it moot. In some cases, the hypothetical scenario might be considered metaphysically impossible, or impossible in any sense at all. David Chalmers says that we can imagine that there are zombies, or persons who are physically identical to us in every way, but who lack consciousness. This is supposed to show that physicalism is false. However, some argue that zombies are inconceivable. We can no more imagine a zombie than we can imagine that 1 + 1 = 3. Others have claimed that the conceivability of a scenario may not entail its possibility. Other criticisms. The use of thought experiments in philosophy has received other criticisms, especially in the philosophy of mind. Daniel Dennett has derisively referred to certain types of thought experiments such as the Chinese room experiment as intuition pumps, claiming they are simply thinly veiled appeals to intuition which fail when carefully analyzed. Another criticism that has been voiced is that some science fiction type thought experiments are too wild to yield clear intuitions, or that any resulting intuitions could not possibly pertain to the real world. Another criticism is that philosophers have used thought experiments and other a priori methods in areas where empirical science should be the primary method of discovery, as for example with issues about the mind.